Good morning to all. Today we are going to see about municipal water treatment or treatment of water for domestic supply. When we are treating the water, there are three stages are there. First one is a primary, second one is a secondary, third one is a tertiary. So first primary treatment, the solid waste can be separated from the water. This is the first primary stage. Secondary treatment is the dissolved biological matters like organic matters, then leaves, woods, like that biological matter can be converted into a solid mass by using a waterborne bacteria. This is the secondary treatment. In the secondary treatment, 95% of suspended molecules should be removed. Last one is a tertiary treatment. In this tertiary treatment, to remove the disinfected bacteria, then biological solid, then chemically and physically infected materials. In this water treatment, there are three type of treatments are there. First one is a physical treatment, second one is a chemical treatment, then last one is a biological treatment. In physical treatment containing screening, sedimentation, flotation and filtration. In chemical treatment containing coagulation, disinfection, precipitation. Then biological treatment containing anaerobic treatment and aerobic treatment. So mostly the municipal water are comes from the river and lake. So these water should be free from colloidal impurities, domestic wastes, then industrial effluents and disease producing bacteria. So we must be treat the water to before the domestic supply. So first we see the primary treatment, the screening process. In this process, to remove the floating materials like leaves, wood pieces from the water, the raw water is allowed to pass through the screen having large number of holes which retains the floating materials and allows the water to pass. So this is the screening to remove the floating materials like leaves, wood pieces, etc. So second one is the aeration process. In this process, we mixing the water with the air is known as aeration. So the main purpose of aeration is to remove the gases like carbon dioxide, hydrogen sulfide and other volatile impurities. So these are removed from the aeration process. Second one, it is also to remove the ferrous and manganese salts as insoluble ferric and magnetic salts. Next, it can be promote a taste of the water and odor of the water. It is also increase the oxygen concentration of the water. This is the aeration process. Aeration is nothing but the water is mixed with the air. So next one is a sedimentation process. In the sedimentation process, to remove the suspended impurities by allowing the water to stand undisturbed for 2 to 6 hours in the big tank. Most of the suspended particles settle down at the bottom due to forces of gravity and they are removed. In the sedimentation process, it removes only 75% of suspended impurities. Next one is a coagulation. In this coagulation method, to add some chemical, that means coagulant, then remove the impurities. So finely divided clay silica does not settle down easily and cannot be removed by sedimentation. In this, impurities are removed by coagulation method. In this coagulation method, we use some certain chemicals that is called coagulant like aluminium sulfate. Aluminium sulfate, we can use this method. It can be added to the water. When the aluminium sulfate is added to the water, it gets hydrolysis to form a gelatinous white precipitate, that is aluminium hydroxide. The gelatinous white precipitate of aluminum hydroxide entraps the finely divided and colloidal impurities, settles to the bottom and can be easily removed. The next one is a filtration process. In filtration process, to remove the bacteria, color of the water, taste of the water and odor of the water and suspended particle by passing the water through the filter bed containing fine sand, coarse sand and gravels. So first we allow the water to the sand filter consists of tank containing a thick top layer of the fine sand followed by coarse sand, fine gravels and coarse gravel. When the water is passed through the filtering medium, it flows through the various beds slowly. The rate of filtration decreases slowly due to the clogging of impurities in the pores of the sand bed. When the rate of filtration becomes very slow, the filtration is stopped and the thick top layer of fine sand is scraped off and replaced with the clean sand. Bacteria are also partially removed by this process. So when we are using the treatment of water in the following steps: screening, aeration, coagulation, precipitation and filtration. The last step is disinfection or sterilization. This is also known as a tertiary treatment. In the sterilization or disinfection process, destroying the harmful bacteria is known as the sterilization or disinfection. The chemical used for this purpose are called disinfectant. This process can be carried out by using ozone, by using ultraviolet radiation, by using chlorination. So first we see about by using ozone. Ozone is a powerful disinfectant and is readily absorbed by water. The ozone is highly unstable and break down into give nascent oxygen. Ozone O3 can be break down into oxygen and nascent oxygen. That means O2 plus single O. The nascent oxygen is a powerful oxidizing agent. It kills the bacteria. The advantages of by using ozone: ozone is a multifunctional agent. It acts as a bleaching, sterilizing, deodorizing agent, and it is also harmless in drinking water. Then disadvantages of ozone is the process is costly and it is also used in large scale method. Next one is ozone is unstable compound, so it cannot be stored for long times. So second one is a UV light radiation, that is ultraviolet radiation. UV rays are produced by passing electric current through mercury vapor lamp. This is particularly useful for sterilizing water in swimming pool. So the advantages of by using ultraviolet radiation: it is no requirement of any chemical, no changes in color, no changes in odor. It is also good cleaning agent. The disadvantages of ultraviolet radiation is it is very costly. Then turbid water cannot be treated. Last one is a chlorination method, mostly widely used for this chlorination method. So in this chlorination method, adding chlorine to the water. So the chlorination can be done in three ways. First one is adding a chlorine gas. Second one adding a chloramine. Third one bleaching powder, adding a bleaching powder. So first we see about by adding chlorine gases. Chlorine gas can be bubbled in the water as very good disinfectant. The advantages of chlorine gas is harmless. It is very harmless. Then it is highly effective and economical. We can widely used for this chlorine gases. So disadvantages is handling is difficult. When we using this chlorine gas, it is difficult to handle. Second one is a excess chlorination causes unpleasant odor. The smell is very different in water when we are using excess of chlorine gases. This is the chlorination. Second one is a chloramine. When chlorine and ammonia are mixed in the ratio 2:1, the compound chloramine is formed. First we add the chlorine in the ammonia to form a chloramine and a hydrochloric acid. In this chloramine can be added to the water to form a ammonia and hypochlorous acid. This chloramine compound decomposes slowly to give chlorine. It is better disinfectant than chlorine. The advantages of chloramine is, first one is it reduces the formation of cancer causing disinfection by product. Second one is it is more stable and thus provide longer lasting residual disinfectant action. So disadvantages: formation of dichloramine and trichloramine affects the taste and odor of the water. It is also cause respiratory problems. So third one is by adding bleaching powder. When bleaching powder is added to the water, it produce hypochlorous acids. In this hypochlorous acids is very powerful germicides. So when we are adding the bleaching powder to the water to form calcium hydroxide and chlorine. In this chlorine again reacts with the water to form hydrochloric acid and hypochlorous acid. So this hypochlorous acid kills the bacteria. Then the advantages of adding bleaching powder: it is eco-friendly and effective disinfectant. It has long shelf life. Then the disadvantages: irritation to skin and respiratory problem, then harmful in aquatic life. Then the bleaching powder is also decomposes in over time. So next one, breakpoint chlorination. When we are adding the chlorine gas or chloramine or bleaching powder, in the breakpoint chlorination is one of the most important in the water treatment process. So chlorine may be added to the water directly as a gas or in the form of chloramine or bleaching powder. During this process, following the impurities present in the water are destroyed. That is, bacteria, organic impurities, reducing substances like iron, hydrogen sulfate, carbon dioxide, etc., and also free from ammonia. When the chlorine is supplied to the water, the result obtained can be depicted graphically in the figure. This graph is drawn between the amount of chlorine added to the water and the residual chlorine. So first the graph is explained based on the curve and points. When the curve OA shows the applied chlorine gas is utilized for the oxidation of reducing substances present in the water. So up to the point A, no chlorine gas is available for disinfectant. Then the curve AB shows that the formation of chloramine and chlorocompound, as the amount of applied chlorine increases, the amount of combined residual chlorine also increases. Then the curve BC shows the destruction of chloramine and chlorocompound, where the combined residual chlorine contents is going on decreasing up to the point C. Then the point C is known as breakpoint chlorination. At this point, all the residual substances, organic impurities, bacteria and ammonia are oxidized and no combined residual chlorine content is available. Free residual chlorine begins to appear and acts as a very good disinfectant. Then the curve CD shows that the free residual chlorine gas is going on increasing as the applied chlorine gas increases. It shows that the sterilization effect is very good. So the definition of breakpoint chlorination is: it is the point where all the bacteria, reducing substances, organic compound and ammonia are completely removed and the applied chlorine begins to act as a powerful disinfectant. This is the definition of breakpoint chlorination. So the advantages of breakpoint chlorination, it is completely remove color, then odor of the water, then bad taste of the water. It is also destroy the bacteria, then biological and organic compounds. Next, it oxidizes all the organic matters and other reducing substances like iron, magnesium, hydrogen sulfide, etc. These are the municipal water treatment or treatment of water. Thank you.